Okay, we have a whole lot of vocabulary that we're going to talk about. It has to do with concurrent or concurrency, is what all these words are related to. Okay, concurrent lines are at least three lines that intersect in a point. So any way you want to draw three lines, as long as they have a point in common, those are concurrent lines. So I could say line A, line B, and line C are concurrent. The point of concurrency would be the point where the lines intersect. So this point would be the point of concurrency. It's where the lines intersect. Okay, now here comes these different triangles that we're going to talk about a couple different places because these are concurrent. These are points of concurrency is what we're going to look at in different places in different triangles. So the first one is circumcenter. And the circumcenter is where perpendicular bisectors of a triangle intersect. So perpendicular bisectors are lines that are in the middle. Remember, bisector means cut in half. Perpendicular means right angle. So if I could find on here a perpendicular bisector, so where I'm going to kind of estimate. So we're going to say I have, this is in the middle, and it's going to make a 90-degree angle. So it's going to look like that. My next one is going to be in the middle of this one. These guys are the same. And it's going to be perpendicular. It might, that doesn't look perpendicular at all, does it? It might go to an angle to the corner, or it might hit it somewhere on the side. It doesn't matter, because what I'm looking for is where the three lines meet. And then we're going to say that this is the middle. And if I draw a perpendicular line, we're going to hope, I'm going to kind of estimate that the point of concurrency is going to be the place where they all meet. Right there. That is the circumcenter. So the circumcenter has perpendicular bisectors. Perpendicular bisectors are equal parts of a right angle. It can be inside or outside the triangle. So I'm looking at my other notes and I'm going, oh, I did that wrong. Okay, so it could look like this. If this is the middle, so these are equal, and I draw a line straight up like this. Okay, and then I draw another perpendicular bisector on this line. I'm gonna keep doing this wrong. This line would go like this. And then the third line is going to be, this is the middle. We're just estimating here. But if I drew a line that was a perpendicular bisector, it would go like that. Then the circumcenter could be out here. So the circumcenter can be inside or outside. Of the triangle, just depending on what kind of triangle it is. And they're perpendicular bisectors. Okay. A circumscribed circle is a circle that goes around the outside. So if I had a circle that looked like a circle, okay, and I drew a triangle inside, my vertices, my points of my triangle, would lie on the edges of the circle. And the circumcenter is the center of the circle. So if you draw a circle around the outside of the triangle, the middle of the circle is the circumcenter. Okay, so the circumcenter would be wherever the middle of the triangle or the circle is. Okay, incenter is also a point of concurrency. It's where three different lines in the middle of the triangle meet, but these lines are going to be angle bisectors. So that means they're going to cut the angles in half. And then you're going to draw those lines out from the angles, and wherever they meet is going to be the incenter. Okay, so let's take this angle right here, and we're going to pretend, because it doesn't really look like it, but we'll start over and we'll go with it anyway. Okay, so these two angles would be the same. These two angles would be the same. These two angles would be the same, not even close, but you get the idea. So where they meet, this right here would be the incenter. So the incenter is where the three lines meet, the concurrent point of concurrency, when you draw angle bisectors. So it's different, it's in a different place than the circumcenter, but it's still just another point that is the center of a triangle found a different way. Okay, and then an inscribed circle is a circle inside the triangle. Inside, let's spell that right. Inside the triangle. So this one is when I have a triangle. I don't know if it's easier to draw the triangle first or the circle first. We'll draw the circle. And then my triangle is going to go like this. Ooh, no. Not like that at all. Because it can only touch it. These are hard to draw. Okay, should have drawn this first. There's one. There's one. And there's one. So the inscribed circle is inside the triangle. And it touches just at one point on each place. And the incenter is the center of this circle. So incenter, because it's inside, that can make sense, right? Is the center of this circle. So these kind of go together, and these kind of go together, because circumcenter has a circle, inscribed or incenter has a circle, and it kind of makes sense that they would have two different circles, would have two different centers depending on if they were drawn outside or inside. Okay, so a few more extra things we could write. In-center has angles in half. Bisectors, right? Circumcenter has sides in half. And perpendicular. So, circumcenter has to have two things. In-center has just cutting the angles in half. Okay, so this is circumcenter cut by or formed by three intersecting perpendicular bisectors. The circumcenter is equal distance from the three vertices. It can be on the inside or the outside. Could lie on the inside, the outside, or on the side. Okay, so it could be on the edge of the triangle. Okay, so this is the part where you have to kind of think about it for a second, because you drew perpendicular lines, but all the lines, I'm going to go back up to the picture. Okay, you drew perpendicular lines, and it's a whole other thing to draw, and I'm kind of don't even know if I should put it on here. Let's try it, and I might erase it. So if you went from, no, I'm going to draw a new picture. Okay, if you had, because that's just going to get messy. Okay, if I have a triangle, and I tell you that that is the circumcenter, then if I drew lines from there to the vertex, to each vertex, then these three lines would be equal to each other. So these are different lines than the lines I drew on my picture to find the circumcenter. But once I find the circumcenter, I can draw lines to the angles, to the vertices, and all three of those lines will be equal. So it's kind of like it flips on you, because for in-center, it's three intersecting angle bisectors. And for this one, the in-center is equidistant from the sides. And it's only on the inside of the circle. It's never, or the triangle, it's never on the outside. Okay, so here's where this picture would be, here's my triangle. Here's the in-center that we found, remember, by drawing angle bisectors. But then if I took that in-center and I drew lines that went to the sides of the triangles, then these three lines would be equal to each other. So I find the in-center by intersecting or doing angle bisectors. But then if I draw lines that are perpendicular to the sides, they're all going to be equal to each other. If that makes sense. That's a lot of information. Go back and think about it. Listen again if you want to. Okay. So when we see circumcenter, we immediately think perpendicular bisectors. So R is this circumcenter. U R. So remember, let's see how I can do this. remember that these are the lines we drew to find the circumcenter. Okay? And this line, and this line is what I was just talking about, are equal to each other. Not the perpendicular bisectors, but the lines that go from the circumcenter to the vertex. Okay, so, and the other thing we know is these guys are equal, these guys are equal, and these guys are equal. That's a lot of little lines. Okay, so if they tell us that O to S is 10, then that means S to P is also 10. If Q to R is 12, then that means all my red lines are going to be 12. P to Q is 22. So if this whole thing is 22, then each one of the little parts is going to be 11 because it's cut in half. Okay. I think I've used all the colors I have. We're going to use black. Okay, so we found OP because it's 10 plus 10. We found RP because that's 12. That's the red line. We found OR, which is also 12. And we found T to P because it was half of 22, which is 11. So there's a lot of lines to keep track of and a lot of parts, but once you figure out where they go, finding all the rest are easy because a lot of stuff's equal to itself or to each other. Okay, so let's go to the next one. MP and LP are angle bisectors. So that means these guys are equal to each other. And these guys are equal to each other. All right. And this line is 5, which means if there's a line here, it's going to be 5, and a line here, that's going to be 5. All these guys are 5, because all the lines that go the shortest distance to the side are going to be 5. This angle is 15, because those angles are equal to each other. So we're looking for, what are we looking for? P to MN is going to be 5 because all from point P to each one of the 3 sides is going to be 5. Okay, to find PMN, which is this little part right here, here's what I need to do. That's my X, right? Which means the other side is X. So I'm going to add all these together. So I have 20 plus 15 plus 15 plus X has to equal 180. So these 3 make 50 plus 2X equals 180. Subtract 50 from both sides. 2X equals 130. X equals 65. So angle, the measure of angle PMN, oops, wrote that wrong, didn't I? PMN equals 65. So each one of those parts of angle M are 65 and they add up to 130. Okay. So we're going to find the circumcenter of a triangle. We're going to find the circumcenter, which means perpendicular bisectors. This is going to be one of those lines that might take a long time, but we can do it. All right, so RSO is R is at 0, 0. S is at 0, 12. Oh, that's S. I almost put 12 and that wouldn't have made sense. And O is at 4, 0. Okay, so here's my triangle. Happens to be a right triangle. Okay, so here's what I need to do. And they made it pretty easy for me. So the first thing I need to do is find the midpoint. Oh, what is that? Okay, we're going to find the midpoint of all three lines. So the midpoint of SR is going to be, and I can use my midpoint formula, which is x1 plus x2 over 2, comma, y1 plus y2 over 2. Luckily, they both have zeros, so the midpoint of SR is going to be 0 plus 12 divided by 2. Nope, that's the y value. That's the y value. And the x value is 0, 0, 0 divided by 2. So 6, 0 is the midpoint. And since I'm on a graph, it's easy for me to draw a perpendicular line because it's just going to follow the graph. Okay, then I'm going to find the midpoint of RO. And again, we have a lot of zeros, right? So we have 0 plus 4 over 2, 0 plus 0 over 2. So that point's going to be 2, comma, 0, which is going to be right there. And again, I can follow the line right there. So I already kind of know where my circumcenter is going to be. It's going to be on the edge of that triangle. But just to make sure, let's do our last line, which is SO. So this one doesn't, well, it's still got some zeros. So we're going to have, for my x value, we're going to have 4 plus 0 divided by 2. And then we're going to have 0 plus 12 divided by 2. So the point on S to O is going to be 2, comma, 6. So if I go over 2 and up 6, oh my goodness, look where it is. It's right there. And then if I wanted to draw a perpendicular bisector, I'm going to kind of estimate, because it looks like it's about 3 over 1, so I'm going to go up 1 over 3, down 1 over 3 is going to be my, my perpendicular, not even close, but there you go. But so my point of concurrency is going to be the one we found, which is 2, comma, 6. So this was the circumcenter because that just happened to be where all those points fell. Okay. So, crunchy peanut butter we're going to talk about on another slide, but this is to help you remember. This is circumcenter, and we're going to do a graphic organizer. So, and then is always better is our in-center. And then we're going to do orthocenter, which is going to be our next one, next lesson. And cold morning is going to be our centroid, which we're going to learn next lesson. So I don't even know if that's on your paper. It's probably not. But crunchy peanut butter is always better on a cold morning, is our little mnemonic to help us remember the 4 different centers we're going to learn. We did circumcenter and in-center. We're going to do orthocenter and centroid. And then that's the 4 points of concurrency in